Well, what is all this stuff down here? Well, based on these general operating conditions, these are some specific things that have to be taken into account when selecting pipe or fittings or flanges or valves. What kind of gaskets are going to be used in the system? When you have to make a branch, how is that branch going to be made? So let's break this down, starting off with pipe. So what kind of pipe we're going to use in an A15 system with this A15 specification? Well, if the pipe is between a ½ inch in diameter and 1½ inches in diameter, we'll be using extra heavyweight pipe, and it needs to be seamless pipe. If we're using 2-inch pipe in an A15 specification, it should be standard weight, and again, it should be seamless pipe. And between 3 and 24-inch pipe, standard weight, and again, seamless. So the idea is, after trial and error, and probably a lot of it, engineers and material scientists have figured out that at 150 pounds of pressure, operating at 175 to 200 degrees 275 to 350 degrees Fahrenheit, that these are more than adequate to withstand that temperature and that pressure. About fittings, between 1/2 inch and 2-inch, where the recommendation is for 3,000-pound forged steel socket weld fittings. And if we're going over 3-inch up to 24-inch, well, we're talking about standard weight fittings that are forged steel but welded together. Right? So for the smaller diameter pipe, socket welds, and for the larger diameter pipe, butt welds. Flanges. All of the flanges are 150-pound flanges. If the pipe is between 1/2 inch and 2 inches, well, these are going to be raised-faced socket weld flanges. But once we get over 2-inch, 3-inch to 24-inch pipes, well, they will have weld neck flanges. Okay, so this just breaks down based on the size, the nominal pipe size, what is required for the pipe weight, for the pipe manufacture process, for the fitting class, for what kind of fitting, what kind of flanges. Okay, we'll go down a little bit. We'll take a look at the valves. Same idea. If we're using gate valves and they are 1/2 inch to 2-inch, they need to be rated between 150 and 800 pounds. Those need to be forged carbon steel valves. Right? And if we're going 3-inch to 24-inch gate valves, 150-pound valves, those will be cast carbon steel, not forged carbon steel. Any globe valves in the system, 1/2 inch to 2-inch, pressure rating, description, right? They'll be forged. If they're over 2 inches, though, they'll be cast. What kind of gaskets are used in this kind of system? It says flexitalic style gaskets. So those are those metal gaskets. You saw one of those when we were taking the midterm. It was the metal ring with the softer metal raised section. That's a flexitalic gasket, 1/8 inch thick. And then last but not least, when you have to make a branch, right? Do we use a T, or do we do a stub in? Should we use an OLET? What's the recommendations based on this pressure at this temperature for the A15 spec? So it looks like they're telling us if the line size is 2 inches or less, use a T and a swedge. Okay, so a swedge is a fitting that we haven't talked about. But the idea is you need to use a T on anything 2 inches or smaller. But on a connection that's 3 inches or larger, well, you can use a stub in if the branch is less than the line size. So if I have an 8-inch pipe and I want to have a 6-inch branch coming off of it, it's perfectly okay to use a stub in. Now, what do you think? What if we had an 8-inch pipe, but we wanted to use an 8-inch T? Could we use a stub in? No, only when the branch is less than the line size. So if you can't use a stub in, well, that means you'd have to use a T. So why is it important to be able to read this chart? Well, think about it. If you are specifying how things need to be connected, do you want to go buy a bunch of T's if they're not necessary? No, that'd be expensive, right? If you could stub in to the header, well, then you do that, right? And you save some dough. And then imagine you're the person, maybe you're not drawing the system or designing the system. Imagine though you're working for some engineering firm and you are purchasing and you are specifying, what we're going to buy for this particular piping skid. Do you really want to be the guy that orders the wrong kind of gate valves for the project? And they drop off $6,000 or $8,000 worth of forged carbon steel gate valves, and they should have been cast carbon steel. You don't really want to be responsible for that, do you? So, being able to read a specification is a good thing. It'll help you as you are designing things. It will also help you as you are involved in other phases of a piping project. So if you haven't gone there yet, why don't you go turn over to page 160. I've got a few questions for you I'd like you to consider. So why don't you pause the video and let's see what you come up with for answers here for this A15 spec. Okay, should a 12 by 10 inch reducing T be used when making a branch connection? Will screwed or socket weld fittings be used on small diameter pipe? What's the designated rating? What's the pipe strength for an 8-inch seamless pipe in this system for an A15 spec? What is the operating temperature for the A15 spec? And then what fittings are going to be used to make a 1-inch branch connection on a 2-inch pipe? So why don't you consider those questions, use the A15 spec in your text, and then we'll see what the answers are.